All right, this is add and subtract rational expressions when you have unlike denominators, so they are different. We have Amika, and Sophia that are trying to subtract a set of fractions with unlike denominators. I have them written down over here. I'm going to go back. Actually, I'm going to talk about this first. So we have unlike denominators. So kind of like before when we were doing, let's say, 3/4 plus 2/3, we could do 4 times 3 to find a similar denominator. Okay, that was from 3 times 4. So we're going to do the same thing over here. We're going to take this denominator and times it by this, and we're going to get a common denominator. So our new denominator is going to be 4z plus 4 times, oops, that's wrong. It should be 7z squared. Okay. I rewrote that. So there we are. So we have our denominator as 4z plus 4 times 7z squared. And we're going to create our numerator. Now, like this, when we do 3 times 4 is 12, we're supposed to do 3 times 3 is 9. So we get a new fraction as 9 over 12. So we have to do the same thing over here. So we have to do 7z squared times 6z plus 1. So 7z squared times 6z plus 1. We also need to do, like earlier, 4 times 3 is 12. Well, 4 times 2 is 8. So we get 8 over 12. And then we add these up and we get 17 over 12. This is from there before. So we also need to do 4z plus 4 times 2. So we have our minus 2. Don't forget that negative. Times our 4z plus 4. All right, that's a 2. All right, now we just have to distribute our 7z squared and our 2. So 7z squared times 6z is 42z cubed plus 7z squared. That's that. And then we're going to do negative 2 times 4z is negative 8z. Negative 2 times 4 is negative 8. We have no like terms to add, so that is done. Okay, now we just want to see which, and sorry, our denominator is going to be 4z plus 4 times 7z squared. Now you can multiply this out, which I think is what our question actually asks us to do, or they do it for us. So let's do it real fast. 7z squared times 4z is 28z cubed, and 7z 28z squared. So let's see what Amika and Sophia have. So they both have 28z cubed plus 28z squared on the bottom. So that's both correct right here. Okay, so that's what I have here. Now when you see 42z cubed plus 7z squared minus 8z minus 8. 42z squared plus 7z squared minus 8. So Sophia is correct and Amika is not. Okay, next question. Next question is right here, and I have it written down. Okay, so 8k cubed over 7k squared, 11 over 3k. We're adding, not the same denominator, so we have to multiply this one by that one to get a new one. So let's do that first. So 7k squared times 3k. Sorry, 7k, not 7k squared. $3k. That's our denominator, and you can multiply it out if you want to, but in this assignment you don't have to. You can just leave it just like this. Now we need to do 3k times this number. So 3k times 8k is, well, 8k cubed is 24k to the 4. And then we need to do 7k plus 2 times 11. So plus 11 times 7k plus 2. So 24k k to 4 plus 11 times 7 is 77k, and 11 times 2 is 22, all over that same denominator. So we'll put that into con. We have a fraction, so hit that first. Um, 24k shift 6, 4 plus 77k plus 22, down arrow, and then we're going to do 7k plus 2 parenthesis 3k. And there we go. Next question. Here's the next question. I have it written down already. It's a subtraction problem. All right, here we go. So, like the last two, we're going to multiply these two together to get a new denominator. So let's create that first. So 3m plus 2 times 5m plus 2. And then we need to do 3m to the fourth times 5m plus 2. And then we need to do negative 4m squared times 3m plus 2. Okay. And then once we distribute this, we'll be done. So 3m, well, I'm going to have to simplify actually. 3m4 times 5m is 15m5 plus 6m. Okay, so I made a mistake. I had to start over a little bit, so I go backwards. So we were at 3m to the 4 times 2 gives us 6m to the 4. And then I come over here, negative 4m squared times 3m is negative 12m cubed. And then we get negative 8m squared all over that denominator. Okay, so I need to redo this top. So it should be, yeah, plus 6m to the 4. Okay, and fixed, checked, and there we go. Next question. All right, so here's the next question. I have it written down already. So we just need to solve it, I guess, and see who Nara or Uzmati is doing it right. So let's start working on it now. So once you multiply both denominators with each other or by each other, 3y plus 7, 5y minus 4. Okay, so we're going to do this denominator times this guy and this by that guy. So we have 5y times 5y minus 4 minus 2 times 3y plus 7. Okay, so now let's do the math. 5y times 5y is 25y squared minus 20y. Then we get minus 6y minus 14. These are like terms. Minus 26y minus 14 with this denominator. Okay, so this should go down here. I just ran out of space. Okay, so let's see which of the two is doing it right. So Uzmati's denominator is wrong. They actually subtracted that denominator. So Uzmati is wrong. Now we need to see if Nara is right. Her numerator is right. 25y squared minus 26y minus 14 is what we have. What I have not done is I have not written my denominator in standard form, which she or he has. So let's have us do that right now. See if she has the same denominator that we have. So 3y times 5y gives us, let's just box method, right? Let's do it. 5y minus 4, 3y and 7. So we get 15y squared minus 12y, 35y, 28. So pull it all out. 15y squared. These are similar. It's 35 minus 12, which gives us 23y plus and minus 28. It does look like what she had. 25y squared minus 26. That's not right. Yeah, so her numerator is, sorry, her denominator, sorry. That's what I was looking at. 15y squared plus 23y minus 28. That is right. So Nara is right. Sorry, I was looking at her denominator and I was looking at her numerator and my denominator. That's why I was confused. And there you go. All done. 3 out of 4.